Welcome back to our lesson practice review. Today we got chapter 3, lesson 9, where we're talking about dividing polynomials. So the main piece of this to understand is how to kind of fill in these boxes, and it's kind of a different way than we've used the area model before. But really we're going to be putting whatever we're dividing by on one side of it, and then we are going to take what we are dividing from, and we need to know that like all of the boxes are going to end up adding to that. So it's a little bit different of a way that we kind of go through this. The nice part is that this first term always goes in the first box, and then we kind of just work from there as we fill this out. So for this example problem here, to kind of show what's happening here, is that I know that, again, these numbers come from here. First term goes in the first box. And now as I work, I know that this needs to multiply by x squared so that I get what's inside this box. Now that I know x squared, I do x squared times 3, which is 3x squared. And then I know that this corner and this corner, actually, let's do this different color. This corner and this corner have to add to whatever the next term is in my original equation. So these two things have to add to negative x squared, which means that this has to be negative 4x squared. And now I'm just repeating that process. Okay, so this times what needs to multiply to negative 4x squared. That would just be negative 2x. Then we multiply negative 2x times 3 to get negative 6x. And now I'm back to the corners, have to add to negative 22x, which would be, what is that, negative 16x. And then now I'm going from 2x multiplied by what would give me negative 16x, and that would be negative 8. 3 times negative 8 is negative 24. And so my final answer here, when I divide them, is whatever I get on the top here. And so when I divide those two, I end up getting x squared minus 2x minus 8. All right, so let's actually do some practice problems here. Number 1, a key used this diagram to divide these two numbers. What's the solution to this division problem? Again, in this one here, we're really just looking for what's on the top, because the stuff on the inside here all adds to this first part of the equation. The left side here, x minus 5, is this part of the equation, which means the top of my diagram here is the solution to this division problem. So this ends up giving me my answer of B. Problems 2 and 3, fill in the diagram to complete the equation. So this is just practice to help us kind of figure these numbers out as we go through. When I'm doing this, I know that these two numbers multiply to get what's in here. So that becomes 3x squared. Next, I need to know that these two numbers, 3x squared and whatever this is going to add to x squared. So that's going to be negative 2x squared. Then what multiplies x times what is negative 2x squared? That would be negative 2x. Multiply that by 3, and I get negative 6x. This number and this number add to negative 14x, which would be negative 8x. And then lastly, x times what is negative 8x, so that would be negative 8. So since I've filled that out, I know that this on the top here is what I would multiply by x plus 3 to get x cubed plus x squared minus 14x minus 24. All right, next one here, number 3. Again, it's not an exact division problem, but we're kind of using what we know about this area model to help us. I know that these two numbers here are going to multiply to whatever this is. That would be negative 4x squared. I need to, this is negative 2x plus 4, so that tells me there's going to be a 4. I'll do that in a different color. Negative 2x plus 4, which means there's a 4 down there, which means x squared times 4 is 4x squared. These two are going to end up, going away, I see, because when I add them together, I get 0. Let's see, I know this number is 4 times itself is equal to 20, so I know that this has to be 5. And then 5 times negative 2x is negative 10x. So it's just kind of a puzzle that we're working out here as we go. In this problem here, the solution to the division problem is just x squared plus 2x plus 5 from the top. And then what we divided from originally is what we get when we add this entire thing together. So negative 2x cubed, these go away. 8x minus 10x is negative 2x plus 20. 4 and 5, write each function as a product of two factors and show your thinking. So this one here, we have our original equation. X minus 4 is a factor, so we're going to divide it by x minus 4. So how I start this problem here, after I've kind of set up this box, is this first term goes in the first box. X times x squared would give me x cubed. X squared times negative 4 is negative 4x squared. My next color here, because I know these corners have to add to negative 3x squared, so that would just be positive x squared. Then x times x would give me x squared. X times negative 4 is negative 4x. Next color, these two have to add to negative 10x, so this has to be negative 6x. X times negative 6 multiplies to negative 6x, and negative 6 times negative 4 is positive 24. And so in this case here, again, 24 and 24 match up, which is good. The last thing here is that the solution to my division problem, or when I factor this, I end up getting x minus 4 times what we have on the top here. So my factored form, x minus 4 times x squared plus x minus 6. Because I know that if I multiplied those two together, I would end up getting what's on the top here. All right, number 5, we are doing the same thing. We have our original equation on top. We have our factor 3x minus 5 that we've now put on the side here. So my factored form is going to be 3x minus 5 times something, which will end up being what's on the top here. My first term is 3x cubed, so that's what goes in my first box, which means that this top has to be x squared. Negative 5 times x squared is negative 5x squared. And then these two have to add to positive x squared, which makes this 6x squared, meaning this has to be 2x. Negative 5 times 2x is negative 10x. These two have to add to negative 55, so this has to be negative 45x. And this has to be negative, what is that, 15? Because 15 times 3 is 45. Negative 15 times negative 5 is a positive, was that 50, 25, 75? And so that works. That's good because my final term here is 75. That looks good. So my final factored form, I'll go back to purple here, is x squared plus 2x minus 15. So this is another way to factor if we know one of these factors works. All right. Number 6 and 7, we have x minus 2 is a factor of g of x. Select all the factors of this function. Use the blank diagram if it helps your thinking. And I definitely will. So x minus 2 is going to go on the outside because I know that that's a factor. My first term here is x cubed, which means this has to be x squared, meaning this has to be negative 2x squared. And these two have to add to 3x squared, so that's got to be 5x squared, which means this has to be 5x. 5x times negative 2 is negative 10x. Next color here, give me a green. These two have to add to negative 34x, so this will be negative 24x. And then from there, I need to just figure out this is negative 24. Negative 24 times negative 2 is positive 48, which checks out because that's our last term here. Okay, so what that means is that the factored form here would be x minus 2. Let's actually do this in a totally different color. X minus 2 times x squared plus 5x minus 24. So already I know one of the factors of g of x is x minus 2 because, first of all, we're told, and second of all, we divided and we got an even whole answer. The next thing here is that all my other answers are just two terms, which leads me to believe that this term here that I factored can be factored again. Again, I could do division if I wanted to, but what I'm really going to be doing is factoring with my diamond and box. First term, first box, last term, last box. 5x needs to be split up into something that multiplies to negative 24x squared, which would be 8x and negative 3x. And then I get x, 8, negative 3. And so really my final factored form here is x minus 2, x plus 8, and x minus 3, which as I go over here, I get a couple more answers. I get F, and I also get B. And so my three solutions here for number 6 are x minus 2, x minus 3, and x plus 8. For number 7, circle the correct graph of g of x. Well, I need to look for those three intercepts. I'm going to have an intercept at negative 8. I'm going to have an intercept at positive 3, and I'm going to have an intercept at positive 2. And they all go through. None of them are bouncing off because when I go through this, they are all multiplicities of 1. And so the only graph that has those exact intercepts is going to be our first one here, because we have negative 8, positive 2, and positive 3. Number 8, fill in the blanks using any integers except 0 to make a true equation. All right, so this one's a little bit tricky. Again, there's probably multiple answers for this one here, but as I go through it, I'm going to start out with just a simple integer of x plus 1, which means that that's what's going to be on the left side here. The key to kind of helping me with this is recognizing that the final solution is just something x to the power 4 plus a constant without any x's. And so what that means is that as I'm going through here, this first term, x here times x cubed here, is going to be x to the power of 4 here. So this one has to be x to the power of 4. And then all of the corners here are going to end up canceling out because I don't have any x cubes, x squareds, or x's in my final solution here. So when I do that here, we'll go ahead and put in front of this, we'll put 2, which means that this ends up becoming 2x cubed here, which means we got 2x to the power 4 on the inside, which means that we have 2x to the power 4 here. And so now as I go through, when I multiply, 1 times 2x cubed, I get 2x cubed. But I know this now has to be negative 2x cubed because there's no 2x cubes in my solution here. So then I know that that's going to be negative 2x squared, which when I multiply, this becomes negative 2x squared. Now these two here have to cancel, so this has to be positive 2x squared, which makes this 2x, which makes this 2x as well, which means that these two have to be opposites, which makes this negative 2x, which means this is negative 2, and this is negative 2. And again, just to see, like once I've kind of finished this part here, I get my negative 2 from the top, I get my positive 2 from the top, I get my negative 2 from the top. And when I multiply all these out, my final bottom right number there is also negative 2. And so, again, just as we see here circled, x plus 1 is this part of our equation. The top here is what we get for the second thing that we are multiplying. And then everything added on the inside is what gets us this last part here. So lots of colors, a little bit tricky to kind of go through, but as you go, you could kind of pick any numbers to get started with, but once you pick, the numbers to get started, then it kind of locks you in on what your answer has to be, because the main thing to focus on is that these corners here have to end up canceling out due to what we see from our solution. All right, problems 8 through 9. Use long division to divide the numbers. So 3 into 4, 26. That goes in once. Then I subtract, and then I bring down the other two numbers. 3 goes into 12 4 times. 12, subtract, 0, bring down the 6. 3 goes into 6, 2 times, so I end up getting 6 no remainder, which means that my solution here is 142. Number 10, 5, how many times does that go into 164? Well, it goes in 0 times here, and I'll go ahead and multiply and subtract and bring down just to stay consistent. 5 goes into 16 3 times, subtract, bring down. 5 goes into 14 2 times, 10, subtract. And then this, because 5 does not go into 4, that means that's my remainder. So my solution here is 32, and then my remainder here goes on top. And then what I originally divided by goes in the denominator. So 32 and 4/5 would be my solution to this one here. That wraps up lesson 9. We are going to continue talking about division and factoring and how that helps us with solving polynomials as we kind of wrap up chapter 3 in the next couple lessons.